Hi guys, welcome back to my channel Pirai Academy. So in this data structure playlist, today we are going to see about queue code implementation. So in previous video we have seen about the queue implementation, but now we are going to start with the coding language. Okay, so I prefer C++ because C++ will be your foundation language. So if you can learn about the C++, it is easy to learn about any other languages like Java, Python, anything. Okay, so the fundamental programming language will be going to be your C++. And in your Java and Python, there is no concept called pointer, right? But in the C++, you will be having this pointer concept. So these are the factors for me to taking this C++ for the code implementation. Okay, fine. So let's get started. So initially, I'll be having a class queue. Okay, inside this, we are going to implement some functions or functionalities of this queue. Now, in my private access specifier, I'll be taking front pointer, rear pointer, and capacity of the queue. Now, int array, this is going to be your array which is going to implement the queue. Can you understand this? Now, inside public, I'll be just taking a constructor. Okay, a constructor. Inside that, you will be giving a parameter as size. Okay, and in this capacity, the data member of this queue class, I'll be storing the size, and an array will be a integer array of that capacity. Now, front pointer will be initialized to 0 and the rear pointer will be initialized to -1. So, these are the fundamentals I have already told you in the implementation itself. Okay. Now, that's a destructor, and this destructor will be helpful to just remove the memory allocation for that particular array. Okay. Now, Boolean is full. So what is the functionality of this Boolean is full? It will be returning whether the queue is full or not, which means whether we can insert further more element or not. If it is full, you cannot insert further more element, right? So that's the reason I am writing this particular function. Now, bool is empty. If it is empty, how we are going to describe it? It will be like if front is greater than the rear, then it is said to be a empty. As I already we saw in the implementation itself, right? And then if the rear is equal to the capacity -1, then it is called full. Can you understand this? Yes. Now NQ operation. So in NQ operation, first of all, I want to check whether the queue is full or not. If it is full, then there itself I can tell you that, hey, we cannot add further more elements because the queue is full. Okay, and then I'll be returning from there. And then if not, then the then statement will be not executed. Then the control flow comes to here array of plus plus rear, which means initially rear will be -1. Now I'll be incrementing it to +1, which is equal to 0. At the 0th index, I will be just initializing the value, the given value here, the parameter. Okay, and then in each time I will be doing a +1 to the rear, and at that particular index I will be inserting or I will be assigning the particular value, and at last I will be telling that it is successful for a message. Okay, now in a DQ similar to NQ, we will be just checking whether the particular array or particular queue is empty. If it is empty, then that itself I can tell you that we cannot do any pop operation or DQ operation, right? Now I want to just tell them like queue is empty and I will be returning from there. If this condition is not satisfied, okay, then control flow will come here and it will be just printing like the particular value at the front. Okay, and the front will be incremented +1. Already I have stated this in the implementation part itself, right? We will be just taking the front value and then we will be just moving to the next point for the front pointer, right? Now peak, this peak will be going to be your top element. Okay, in this top element I want to check whether the queue is empty. If it is empty, I will be just doing that it is empty. Else what should I do? I'll be taking the front element Okay, the front pointer will be pointing to the first element, right? So that's going to be a front element, and I will just printing it out. Okay, and then there's the additional functionality called display. In this display function, I will just displaying all the values in the queue. Can you understand this? Yes. Now it is empty. If it is empty, then what should I do? I just print queue is empty. I don't want to just go and print all the elements in the queue. I just print queue is empty. Else, what should I do? Queues element. I'll be just printing the queues element. Like I'll be putting the for loop up to from front up to the rear pointer. Okay, and I will be printing all the elements in those things. Okay, and here comes the main method. Okay, so from here, from this class starting up to this part, the class is over. Okay, we also implemented using the linked list that I will be telling you in the next video. As of now, this entire video will be only of array. Okay, we are going to implement the queues using the array. So up to this, the class of the queue is finished. Now we are going for the main method. Inside the main method, I'll be getting the size and the size from the user. First of all, I will be getting the size from the user, and then I'll be just creating a queue object. Okay, I'm creating a queue object of size that is given by the user. Can you understand this? Yes. So the prerequisite of this will be your oops concept. Okay, without knowing those oops concepts, you cannot figure it out how this class works. Okay. Now I'll be putting a do while so that I can be running this again and again. Okay. So this is a simple menu driven program. Already you know the menu driven, the choice taking program, user choice. Okay. Here I'll be having 1 as enqueue, 2 as dequeue, 3 as peak, 4 as display, 5 as execute. Okay, and with respect to those choices from the user, I will just using those objects to just access my member function. Okay, like enqueue, dequeue, peak, display. Fine. So let me run this so that you can understand this clearly. So see, first of all, it is asking for the size. So my size will be 5. Okay. Now I am first going to do an enqueue operation of 5. Okay. 5 is inserted successfully. Now again I am doing an enqueue operation for 10. So 10 is executed successfully. Now again I am going to enqueue for 22. Again I am going to enqueue another 22. Since your queue can have a duplicate values. Okay. And then again I will be doing 1 and 100. Okay. If I try to insert any other element, like for example 5. Here it's stating that hey, queue is full. Because we already have 5 elements: 5, 10, 22, 22, 100. For example, I can execute here itself 4. So see here, the queue elements are 5, 10, 22, 22, 100. Okay, so that's the reason why it is telling me that the hey, queue is full. Okay, if I do a DQ, the pop operation, okay, first of all, it is taking out the 5. It is taking out 5, not 100. Can you understand this? Okay. Now, if I again do a enqueue operation for something value like 23, then now also the queue is full because it is a normal queue, it is not a circular queue. In circular queue only, the rear pointer, once it attains the last element, okay, then it again goes to the 0th index. Can you understand this? But here it is a queue, normal queue. So it doesn't go back. It will be always going in front of the front. In the empty queue only, the front will be greater than the rear. Can you understand this? Okay. Now again I will be doing a DQ operation. DQ. So 10. Now if I do a peak operation, then 22 will be my answer. Can you understand this? Okay. Now I will be doing a DQ, 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 again DQ. Then Q is empty. Q is empty. Now if I do a peak operation, again Q is empty. If I do NQ operation for something value like this, now what is Q is full. So now hope you understand what is the disadvantage when we are going to implement by using the array data structure. Yes. So this is one of the kind of array data structure. To overcome this disadvantage, we will be just shifting all the values to the left side. For example, if this is my array, okay, 1, 2, 3, 4. Now here 10, here 5, 22, 22, 100. For example, okay. Now if I just doing a DQ operation, then this 10 will be popped out, right? Now to avoid the memory loss, see here there are much memory is lost, right? Because the queue has a 5 memory, but still the queue is full and also empty. Can you understand this? To overcome this problem, we'll be just slightly doing some variation, like I'll be just shifting this 5 to here, this 22 to here, this 22 to here, this 100 to here, so that my resultant array will be looks like 5, 22, 22, 100, and then empty space. Now you have one slot to insert. Can you understand this? So this is a simpler way of implementing the queue without that error. In the previous case, we will be losing this slot entirely. Now we will be only having a size of 4. To avoid this, we can move everything to the left side, which means shift every element one time in the left. Okay, so that we will be having a one slot at the end. Can you understand this? But by doing this, my time complexity will be rising to of n, because I will be just taking all the n elements and shifting to the left hand side. So the time complexity will be O of n. Now hope you understand what is the mistake or what is the minor change we want to do in the previous implementation to rectify the memory loss. I understand it? But as of now, by doing this approach, the code implementation approach, you will be getting the time complexity as O of 1. But it is not space efficient. Meanwhile, by doing this, the shift method, you will be having a time complexity of O of n, but it will be a space efficient. Can you understand this? So I can also implement now. It will be so simple. So see here, these are the things that are going to be changed to change our error. Okay, there is an error occurring, right? So now we can just add any number of elements up to that size. Okay, so just see here, let me execute this so that you can understand this clearly. So first of all, size will be 5, and then n cube 5, again n cube 10, again n cube 22, again n cube 22, again n cube 100. Okay, now we have 5 elements. Okay, now if I do a DQ operation, 5 is deleted. Now again if I do a NQ operation, it will be asking some value, and I have given that value and it is inserted successfully. Hope you understand this. So in our previous implementation, here it will be like queue is full, but now it is inserting some values into the queue. Can you understand this? But still our time complexity for this current implementation will be over n for the DQ operation. Okay, so if I use to display some values here, 10, 22, 22, 100, 23. Hope you understand this small change. Okay, and see here, in our previous example, there is a there is a time efficient, but it is not much more space efficient. Okay, although there is a space to store in that array, we are not going to store it. But the current implementation, we will be storing the values efficiently, but our time complexity will be rising. Know the difference. So I intentionally took that implementation. Then now I am just correcting those versions to become this implementation, so that you can understand how we are going to implement the queue using the array in two types. Okay, only in the DQ functionality alone. Hope you understand this entire code. Okay, and if you want the code in Python or Java, you can just see in the description. I'll be just giving you the link for Python and Java code, So as of now, that's it for this implementation. In our upcoming videos, we'll be just seeing other types of views and other types of implementation for those views. Okay. And if you really like this video, subscribe to my channel. Don't skip any videos in this playlist because all videos will be helpful once you are appearing for the competitive programming. And if you have any doubts in this implementation, or if you have any errors, if you have found any errors in this implementation, just feel free to ask in the comment section. I'll be just telling you what will be there, or I'll be clarifying your doubts. Thank you.